meetings.
All
All right,
right,
so
we're gonna start today with Sam Phillips showing some of the code that he's written. And maybe you could make the font a little bigger.
I turn on light mode because I knew it wasn't gonna. The dark stuff is hard even for me to see sometimes. Yeah, so I have 2 or 3, depending on time, things we can just kind of peruse. Yeah. What else? Yeah. So this one is kind of a basic data frame thing. This is a smaller example, kind of, and it's not quite complete. I actually had it's porting of something that I had written in Racket, although in Racket I was punning a lot of like the built-in types. So I had generics and they were, had defaults for vectors and hash tables and stuff like that for doing stuff. But in the Rhombus one, I'm using like real classes for everything, just wrapping them up instead of trying to pun them. And yeah, so it's a basic data frame. The design is the data frame holds some number of columns, and it has an index, and the index maps from an integer to an integer, and then in the columns they're arranged like vectors or arrays so that you can index into those. And part of the idea is that the indexes are independent, so that if you wanted to do like sorted data frame, you just resort the index. You don't have to regenerate the vectors for each of the columns, stuff like that. So yeah, so this is just like very basic. This is why I asked the question of Sora can I use the pretty printer describe mechanism to do to make tabular data. I still haven't quite worked out how I want to do this, but it's kind of the basic stuff. So yeah, I got a reducer working. And that's actually what most of the data or like the code is right now. I've not really poked at much else or had time to. But yeah, so yeah, just kind of uses a bunch of vectors as a builder under the sheets while it does the reducer. Yep. So not much to this. It's pretty straightforward. I think I did some, take advantage of this one doesn't have it yet, but I took advantage under like the index to use. Did I take advantage of it? Yes, to use indexable so that I can, you can use the square brace notation, and then similarly for like the columns. Yeah. Pretty much the one thing is it's kind of funky. I think we've had this discussion before, going between immutables. So I just brought in some renames from Racket to make that a little more straightforward.
So you need immutable vectors somewhere?
Yeah, so I'm usually trying to use, so the index, there's actual index as an interface, but there's 2 main classes that I have right now. One is just by identity, so that's just 1-to-1, and then the other one is by an array. But I want to make them immutable because I don't want someone going and changing the indexing underneath it. So
Okay, I ran
yeah.
into needing, or not myself needing immutable arrays, but I think we need to add it in addition because of a immutable array of, and an annotation makes sense in a way that array of and an annotation doesn't, in terms of sort of eager checking and so on. So,
Mm-hmm.
so yeah, I do
Oh
think
yeah.
we
Yeah,
add it.
like here I have a mutable array and
Right. So that array
yeah.
of, there actually is no array of anymore, right? That's a temporary stub for compatibility.
All right.
Yeah.
Yeah. So That's most of this. There's not a lot to see yet. I'm hoping to, I have in the racket implementation, which is it's pretty much is mostly the same as this one. I mean, as far as how the structures are, I've implemented parts of or re-implemented parts of Sawzall so that you can do little pipelining stuff. But I'm just wondering, I'm still kind of feeling the design space to see how that would how that translates to this. I know that we have I know Sam provided a threading operator that's in the compat library that we can use for that too, but I'm not sure how I feel about it yet. Just haven't tried enough stuff out. So yeah. And some of the Sawzall operators might be a little weird because they might feel like they need blocks. So how do you write something that's like a data frame and then like I mean maybe it's obvious and maybe it will just work, but like a rename, and this is like a special operator that renames columns or something, right? I'm not sure yet. Anyway, it's
dumb question, but how do you use values? Like, I mean, is it like used in any meaningful way here?
In this one? So
Yeah.
if it's just each one maps to the column. So this makes I can explain this more. This reducer creates a data frame with columns A and B. So if
My
you had it,
suspicion based on experience here is that you're unlikely to want values going forward there. Like once it gets big, values is less fun.
And you want to use a list instead, or some kind of data structure?
An array probably in Rhombus that like once you have big data, not in the like capital B big data sense, but in the like there are 150 columns in this data frame. 150 values is less nice to work with.
Yeah, and this interface is more for like in most of the cases where I work, it's really 1 or 2 columns, and then you do a billion transformations that make you have 150 columns, right? So
yeah. I mean, I think the comprehension syntax is often not creating a lot of columns, but it gets annoying dealing with values. If you look at, I think that if you look at the /data frame form in like Alex's library or in Sawzall, I don't think it uses values.
I don't have it in here. I thought it did. Maybe it doesn't. It's a data frame. It does.
I stand corrected.
Yeah, and that's where I cribbed part of the design from. So,
but still, this does remind me of a problem that he ran into, where once there were like sort of values of too many values in a single values call, it just like turned what should have been linear things into quadratic, turned what should have been quadratic things into cubic, and it was not good for performance.
Why is that the case? Is it because like many values are inefficient?
is this a runtime or a compile time? Or is this like in this for value or for data frame sense, or is it just in general with too many values?
So when you're converting back and forth between values and something else, there's like a linear cost to converting that. And that includes call with values, converting it between lists, and that includes like calling values with apply with a list. And I'm not sure what happens when you just use define values directly with a fixed number of values. That might be better. I think most of the problems that came up in Key were to do with converting to and from lists, because that's basically the only way to convert an unknown number of values to and or from anything.
Yeah. Anyway, anything else? Going to my more demo-y demo.
Has the for syntax worked okay for you? Has it been very prominent?
This one's working all right. I mean, it's mostly I'm using it for loading up stuff.
I found it to be a little bit heavyweight, is why I ask. I feel like it should be just slightly lighter. But
Oh,
Yeah.
like with the eaches and everything.
yeah, the edges.
I'm still, it's growing on me.
Well, I think we should explore an intermediate path.
Okay. Yeah, I mean, that was when,
More than that, but let's not interrupt too much.
oh yeah, I just a comment is that when you initially proposed it, I was dubious, but it's, you know, it makes sense. So that part's nice. But yeah, heaviness is a hard thing to deal with on this, I think, or hard area.
Yeah, I think the solution may be to have an intermediate form that covers many patterns. Just more variance, of course. But speak for later. Let's see the next demo.
So
Well, wait, I had a little question. What were all
okay.
these falses at the bottom?
Oh, it's because it when it does the down there. Let me close it all out so that net didn't exist. When it allocates it, it's actually allocating a bunch of mutable arrays to start, and it's just doubling the size, but the index point doesn't point to those ones. So it's actually on the to-do list is to have a compact for series operation that will just trim all that stuff out. So
Got it.
only valid indices will exist in the series. Yeah. Cool. All right. So semi-related. In my so my day job is mostly like transmitting stuff from point A to point B and doing transformations along the way. So dataframes just kind of falls into that. I deal with a lot of tools that do stuff kind of what this one is, which is take some input from somewhere, annotate it, transform it, add some other stuff on an event by event basis, and then send it to like an analytics platform. So this is kind of a POC that I've been working on for a few weeks when I get a chance. When Matthew asked me to do a demo, I started adding like 10 features yesterday to try to get it to look more substantial, including up to about 20 minutes before the talk. So I'm pretty sure everything's going to work. So let's, so basically, the design is there's a bunch of things and they're connected together, right? So I have some sources, I have some things I pipe things through, and I have some sinks, right? And this is just a very simple one where it takes a source. This is a standard in, comes from standard in, and adds an annotation for the time, and then dumps that whatever it gets on standard out as JSON. And then a bunch of extra stuff to make it more operational friendly. So there's a supervisor that kind of handles the life cycle of these things. And yeah, that's it. So let me show it real fast, and then we can kind of show it how it pieces fit together. All right, so it has some logging, very, very simple amount of logging. And then we can send messages. So send some messages. Let's make it big, and now I've made it horribly to see. There we go. So pretty basic. So yeah, pretty straightforward. And then, catches break, shuts everything off. So where to start? So yeah, the basic part is that we got these things that can be supervised and supervisors, which also can be supervised. So yeah, there's just this is very fun, lots of state and threads and stuff. So it handles a lot of the bookkeeping. Yeah, there's a main start thing. We keep track of what our transitions are so that, it can be queried externally outside the thread. We have some flags for stop if we are currently stopping, or if we are stopped, and this is then, like, in the main thread here, we go call some callbacks, very, very oopy. So start to running process was all the happy stuff happens. Then here's our shutting down process. If we get a exception, we're going to go to the dead state. We'll run a dead handler. We'll mark ourselves as dead. So if anyone asks, or if we're checking it, the supervisor uses some of this. I don't have I haven't really thought out all the magic stuff. I looked at some Erlang supervisor stuff, and just having the time to sit down and implement some of the different basic strategies. It says haven't had a chance yet, but so this one pretty much just has very simple strategy where it does nothing. But it starts up, a bunch of children, and then when it's ready to shut them down, it shuts down the children. So pretty straightforward. So yeah, and this one, go for it.
Sorry, I did a lot of work with Elixir, and so I have some familiarity with the OTP and supervisor. So later, if you want someone to bounce ideas off of, I'd be happy to chat.
Oh yeah, sure. Yeah. Yeah, I'm like, my Erlang experience is probably 13 years back in a bunch of experiments. So it's all, I'm aware of it, just not versed in it. So yeah. What else do? Yeah, so a lot of this. Oh, so one of the things is I brought in a lot. I made some logging syntax, which is nice. It kind of wraps around the existing racket logging. What else? So yeah, if I go, so this is actually, I put this in the compat kind of package that curating. One thing to note, my insight about this is that sometimes I still look at these and it's just pretty noisy. If I'm like paying real attention, I can go, okay, I know what this is doing. But yeah, it's pretty, I mean, it works, which is great. And it actually isn't a lot of code. So that's also good. That's my feeling about that.
Yeah, bridge
That was
code
really
has
useful
this.
to have.
Bridge code has this particular flavor, doesn't it? With a lot of annote macros and dot macros and things like that.
Yeah. Yeah, and this one, it's a little even a little more weird because what I'm making is something that I want to, I want to do more parsing than normal. And this is definitely the more advanced, probably one of the more advanced cases relatively than people would normally do. But yeah.
Yeah, the whole Rhombus compat library is full of code that looks much like this. That feels like after you write 3 of them, it feels like this all ought to be automated away, but it is not obvious what the appropriate automation or whether it's right, because it never ends up, you write a bunch of this code and then it's not as nice as having something that was actually built in Rhombus where like the static and dynamic pieces line up more nicely, and so then you're left with like, do I really want to make this easier when the right thing is for this not to exist? And yeah, I think those are important questions as we go forward from here.
I think you're saying sometimes it's better to just re-implement it than try to use the other library.
Well,
So for something like logging,
I mean, I raised a question about this a month or 2 ago, like, do you want to re-implement it or like wrap it in something where you like add a bunch of stub methods that do the call the racket function that does the right thing, or like this is a very thin wrapper where after expansion you basically get identical code to what you would have written in Racket, whereas a different approach would be you write a class that has a single field, which is a racket logger, and then you have a bunch of methods that each of which calls, as its implementation, calls some racket function.
Yeah, that's a choice for very runtime or very value oriented things, but the logger, there's a lot of syntax here. And so I don't think in the wrapping class strategy, this would be more typical of things where you have to work more at a syntax level, right?
Yeah, although I mean, things are gonna be all over the spectrum here, but sometimes you can write, and it's not clear which one is even less code to write. But yeah, I just think there's multiple wrapping strategies, and then there's this not wrapping strategy of just writing your own code that's just all in Rhombus.
Yeah, one of the ones that I've been playing with was like the streams, and I think I took a strategy where I was just kind of like try to make it work in the static realm, but probably the right strategy is to implement or to expose the stream interface as an interface and then just make a Rhombus stream that is pure Rhombus, but it is a racket stream because it just implements the interface, right? And I'm wondering how many of other of those are, but that one also kind of begs like, what happens when someone hands your code a racket stream that's not a Rhombus stream, then what happens, right? So or the answer is don't do that. I don't treat it as opaque. So yeah, logging's fun. So yeah, just then this I ended up going, let me see. So yeah, then we have processors, which pretty much they are the same as the supervisable, but their process method just syncs on either the stopping event, which we just handle and it discard the result because the main handler just will then jump to doing all the stopping code, or we go to process event, which is an abstract method which should return an event, and that event should you know, tail call back into process if you need to, or do something else. So let me go to, actually the pipe one's probably the simpler one to look at. So its process event gets, okay, probably should explain this a little bit. So these are just pretty much wrappers around, in this case, input connect and output connect are interfaces, and the concrete implementation of them that I currently use is just based on a synchronous channel. And mainly the reason why I made them interfaces is because, you know, they're not like a channel you can you can get or put freely on it, right? Whereas this one, I want it to be like the end of the pipe. So it's either the end that you put stuff in, or it's the end you take stuff out of. So that's why I made that a different abstraction. So any case, the input connect has a receive event. Output connect also has a send event. And then on top of those, there's send and receive, just like a channel normally has. If you don't like to deal with events, but I like events, they're fun. So in this case, we're going to take the input event, or sorry, input connect, receive event. We're going to handle it. We're going to call the on event handler with our value. And then when we call that, we're going to send, we're going to add a tag. The tag is just going to be time by default. And we're going to hit time now, and we're going to process it. The reason why I had the tag is in there, in case you want to know, is that you could put a time tag at the beginning of a pipeline of a bunch of stuff and one at the end and measure the difference, and for profiling purposes. In some other system that doesn't know about all of this. So yeah, that's that. The port stuff is, you know, pretty straightforward. The process event's more noisy because it's doing more stuff. And I would change this one because I want to add a abstraction about how events are serialized and deserialized, and I added the serialize just so I can do JSON going out, but I haven't had a deserialized, so JSON coming in part. And yeah, ports, so you could just connect these to the network somewhere, or, you know, it's a nice abstraction. It works out for this. What else? That's about it. JSON, it literally wrote this morning, so it's just a pretty basic wrapping. Yeah. I love questions.
What's your implementation of SERD? Which is and where'd you get that clever name?
I made it up myself.
I'm kidding. That's pretty simple.
Yeah. Yeah.
So you haven't done any sort of automatic generation, automatically figuring out how to serialize and deserialize?
No, but I put some thought into it because I have been trying to use the Amazon's Boto library, which has big API descriptions, and turn that into something usable from the racket level. So
what is
some of that on
How
the racket level is
spelled?
informed by some of the Rhombus stuff, but it's all in progress right now. Yeah.
How is Boto spelled?
BOTO. And because I love puns, the racket one is called Boto, or like a boat, BOATO. But it is unpublished because it is unfinished. So yeah, Amazon has these huge descriptions in JSON. And so you take those big descriptions and then you can go and unparse their XML, or you can or parse their XML into a data structure, or vice versa, take a data structure and you turn it into a HTTP request. It's big and it's messy. But it's the same thing that it's very similar to what the risotto library does in Rust, which is their implementation. But yeah, I haven't done much in like real serializing on the Rhombus side yet. Yeah, just kind of thought about it a little bit. Something that I did, so I did make a annotation for events, which is not in this. This is actually also in the compat library, and I added it to the threads library because that seemed to be make the most sense for now, at least. You want to kind of use these together. So I have to find where I put it. Yeah, so events are pretty generic, and I pretty much just added, basics stuff for handle and wrap. Yeah.
Is there any reason that handle and wrap need to be through dot macro here instead of just?
No, it just looks nicer.
Oh, okay. But they could be functions exported.
Yeah, and
Yes.
it's kind of how, I mean,
Okay,
even
yeah.
also
Alright,
does it there as well. That seemed to be more like how a lot of these other ones are, or kind of how the API looks. So
Is there any advantage to lines 56?
let me see.
Or is it just already covered by that? Well, wrap is in both places. And handles.
Oh no, so this is a namespace. So you're not gonna get,
I get it. I get it.
yeah. So you can do the namespace, you can do it either EVT dot wrap, or you can do an actual event dot wrap.
Okay, so I've asked you the same question before.
Yeah,
I keep
and
forgetting.
I thought about adding EVT dot sync, but I'm not sure how I feel about that yet. But it would make it really kind of what is the word? It's like in OO languages where you do this dot this fluent. It makes it more fluent. So but I haven't done it yet.
Yeah.
Sorry, what?
I've generally done those things when there's two ways to do it, do both.
Yeah.
And I've been happy with that choice.
Yeah, I mean, you could always do, like, I was also thinking like maybe there's an event EVT dot, or not dot, but EVT, some operator that does as an event combiner where it would wrap that with choose event, and but yeah, just kind of like thinking in, or working through what kind of things we can do with that are different, that makes sense.
Yep.
Or at least makes sense to me. Yeah. So what else? Yeah, things that come out of strings or string views. That's another, that's not too much of a pain point, because generally when it at the point where it touches the racket code, I just do a toString and be done with it. That seems to be working so far. Haven't stressed, this hasn't been stress tested or anything, so I don't know how well it performs. It works good enough for making stuff go from A to B. Most of the time things like this, we're not they're really IO bound stuff, so it's not pushing through a lot of stuff at once necessarily. That's all I have, really.
So I guess one
Yeah.
thing just for the people who might watch this recording in the future. This business with the dot macro versus, line 56 dot macro and the namespaces versus classes. This is really connected to that discussion we had earlier about different choices of making bridges, right? So I think when I find that when I'm just writing Rhombus code that's not a bridge, that I almost never use dot macro and these sorts of things. I use class and namespace to some extent. So
Yeah.
just to record the experience so far here and make it more clear to people who are looking at these examples.
Yeah, and I think part of that is that there's this, in Rhombus, you're sort of led to this dot-oriented programming approach, but like simple racket wrappers will not get you there. And so then you write the kind of code that's on the screen at the moment to bridge that gap. And if it's easy to write a racket wrapper that just forwards a bunch of functions with appropriate Rhombus compatible names, but then you're writing it in the other way and it doesn't feel Rhombusy. And so then you write a bunch of dot macros.
Glue. Yeah. And then there's an unfortunate part where the dynamic stuff isn't, work too. So we use almost all of the stuff I write is in Rhombus static, just to make it easier.
Yeah, I agree. I write almost everything in Rhombus static too. Okay, is that everything you wanted to show?
Yeah,
Sam?
I think it is. I don't think there's anything else, nothing else massive in here. Yep. Lots
We have
of glue.
little time. I could show Shplait stuff if people want to see that.
First of all, how do you pronounce it?
Shplait.
Shplait.
Yeah.
Just start pronouncing it and then don't stop.
There you go. Yeah, since it's just for a class, I didn't want to use a good word for it. So I think you've probably all seen some of this code. It looks very similar to plate code, just translated almost line by line. In fact, that's how much of this code arrived. The parsers are different. And jumping down to test cases here. So students are implementing a language that looks like this, which is similar, but not exactly Rhombusy. And Shplait itself is similar, but not exactly Rhombusy. So the check form here looks like Rhombus's check form, but it's more constrained and things like that. And colon, it's not just an annotation, it really is a type. So if I get it wrong here and say that numb holds strings, then we'll get the sort of type error where it just says inference. Basically, it just says string versus number, and here's all the places that seemed relevant to that, right? In traditional kind of minimal error reporting. So change that back so I don't forget. Here's another example that's a little bit interesting. This is at the store passing point in the course, where you have to pair together a result with an updated store. And so I take this opportunity to show them a little macro here. So this again looks pretty much like a Rhombus macro, although it is the rules for escapes are just slightly different in ways that simplify it, but don't really affect what they need to do in these simple cases. The point being that it's just a Rhombus macro also works with the rest of Shplait. This is towards the end of the course where they're writing classes and methods, which is just a lot more stuff, but they can parse these kinds of things out. So the real big attraction of S expressions for a class like this is that you minimize the parsing work, but Shplait lets us have similarly minimal, and actually it turns out to be even easier just because I've invested a little more work in the pattern matching and putting that into the language. Going to things that are interesting for Rhombus. This is the type inference engine unifier here. It's ported straight from Racket. But it's where I found a pattern that I had not anticipated, which is that the Racket code has a conditional and is it a Boolean, is it a symbol, is it an arrow type, and so on as a kind. And I found it worked best to use match for that, so that so I'm matching on type, and then this case is type :arrow. So what that does is let me use type.args and type.result here with static information. It knows that those are valid fields. So it's kind of simulating the flow-based typing or something like that by shadowing names. And it's reasonably convenient to write this way. And it's also nice that I can mix different kinds of conditionals, ones that are checking instance of basically, and ones that are other things. I mean, maybe not an example of that here, but in other places. When I first wrote this code, it was all pattern matching style. And it got really tedious because I didn't want to write out all the fields of tuple of, say, tuple of is not the problem, it's data type was the problem. A bunch of fields that I don't really care about most of the time. And this style lets me use the dot notation. So I thought that was interesting how that panned out. It wasn't obvious to me at the beginning. Jumping to the other extreme, and I think I just closed the tab that I meant to show. Let me rearrange some things here. Yeah, I did. Let me find it again. That's right. All right, so here's the part that's the only part that's not in Rhombus is the glue to get the language going. So right now we still have to have module reader, module configure runtime, and so on in parentheses, because I don't yet have a bridge for those in Rhombus. And then this is more complicated than it needs to be to work around problems in the current Racket release. But basically the strategy is we're inside module begin. So first we're going to find all the type definitions. And we do this as a separate pass because we want to have mutual dependencies between the types. Like value has an environment in it. Environment is an abbreviation for a list of binding. A binding has a value inside it, right? Which of course goes back to environments through closures. So that's why we start out with doing a pass to find the top level definitions. And then we do local expand on the whole module body. And then we finish the current frame that is doing the polymorphism inference.
So that means that you can't have macros that expand to type definitions, right?
You cannot have macros that expand to type definitions. That's correct. The main simplification I've made is that there's only expression macros. Right. So all the unification, all the unify calls are going to be during this local expand here. And then at the end, we see what's left over, what unification hasn't constrained, and infer polymorphism from that. And then after we do that, there's another pile of somewhat tedious code here that is building a registration of the type definition. So basically, this is recording the types so that we have them when we import into another module or when we work at the REPL. And then after we do that, then we handle all the submodules because that needs to be in place for the submodules that can refer to them. So this is a little awkward, and I've experimented with ways of not having to use local expand to make it more in line, and it can work almost. There's just a little thing missing from Racket that I may go back and change. But the big picture is the strategy is you can do some sort of outside of the macro system work first if necessary, and in this case it's necessary to get the types to see each other, then rely on expansion to do the type checking work, then finish up. And then we have some extra finishing up in this case. So when I say that type checking happens as we go, it's like here is the implementation of the not operation. I'm going to export it as exclamation mark, but define it locally as not. Not as a macro that has one expression. So this expression, because of it's an expression macro, it means that right has already been parsed as an expression. And lookup type uses Rhombus's static information to get the type off of it. Okay, so somehow the expansion of that, the parsing of that expression has put type information on it. And when I say somehow, well, we can see how that works here for not, because it's going to expand to a use of brackets, exclamation mark, for not, but also wrap it to say this produces a Boolean. There's all sorts of extra stuff here that's basically source location for error reporting, right? So that's why Boolean has the expression inside of it, so it can talk about that expression if it needs to report errors. So we look up the right-hand side, we unify its type with Boolean, and then we put it together back with the exclamation mark, declaring that the whole result will also have type Boolean. One minor thing is lookup type returns two things. It returns the type, but also a new version of the expression, because it may have needed to force some extra expansion. And just returning those both at the same time makes it less likely that I forget to deal with both of them. And the rest of this file is just more of the same stuff, but sometimes, plus and minus and times and divide, they're all very similar. So this is what it looks like when you have macro generating macros in Rhombus. You end up with these $ escaping $signs. My experience is this works okay for macro generating macros, but when you have macro generating macros and try to nest them this way, then it becomes too hard and you should do something else. Probably like not generating so much code, but sending it off to compile time helpers or something like that. Any questions on any of this? Can just show a little bit more. Here's arrays. So the array form, there's a bunch of elements, and these elements all need to have the same type for the array to have a type. So what does this do? So this $ is escaping. This is lems and back into a quoted things. So this is like when you do tilde and in syntax parse to give a name to something. That's what that pattern looks like in a Rhombus macro. So I'm giving the name lems to whatever I match here. And what I'm matching is a sequence of elements, each of which is parsed as an expression. So this macro, unlike the exclamation mark macro, this one is taking care of forcing the parsing of sub-expressions itself, because they're in parentheses afterwards.
I'm
Sorry?
I'm trying to understand the ordering and dependency issues here. So because you have macros and but also these macros can depend on the types. So
okay, so not quite. So we cannot, Shplait doesn't do any sort of type directed expansion, right?
But you could.
No. So the way I'm getting around that here is I'm getting a type and just unifying it. So the type that I get back from these sub-expressions may just be alpha or something like that. I might not know what it is yet. So I can't expand in different ways based on what's coming in here. Just to make that concrete, here I'm implementing indexing for arrays, but I cannot use the same notation to index into lists, because I need to know whether I have an array or a list in order to give it the right kind of type. Right? So,
I mean, to be pedantic, you could do stuff dependent on the type, but the type could be very boring and you don't really know what alpha will mean later, but as in lookup type returns a type. It's just that it may be very hard to interpret that type because it might be a type variable whose constraints are not known to you.
Basically, I think you can't do you can't make any use of that in the general case.
Right.
It may not be just
you cannot write something where you process the type of an expression in a useful way, but you could check whether the type variable is alpha or beta and expand to arbitrarily different things.
No, I don't think you could, because alpha and beta might be unified later.
Right. That's what I mean, is that in the same way that you can write racket macros that behave in ways that your users will find unexpected.
Yeah, I mean, maybe there's some more precise thing here, but I think the simple answer is no, it just doesn't work.
Well, you get a system you will be unhappy with, but there is a thing there that types are not opaque at this level.
Okay. Maybe, but to keep it simpler, I can say that it doesn't try to do any sort of type sensitive expansion. Okay, so again, this is matching just the macro keyword array that we're going to rename as we export it from sh array to array. And then parenthesize sequence of elements, each of which is parsed as an expression. For each of those, we look up its type, and you start to see a lot of dots. So we're getting into the part, this repetition notation is very heavily used in the Shplait implementation. So here we have matched a sequence of elements and parsed them. Then we're getting all of their types, which actually gives us the type and the element. And then we want to do this side affecting operation unify do on each of those elements with the single type variable. Function pass is currently the name of void. So I just need something to wrap around this repetition. So this is one place for improvement. I could have just used square brackets, which would mean construct a list that I discard. And even though the optimizer would probably take care of that for me and not actually construct the list, just using function pass clarifies that I'm doing this just for a side effect. So I just want to map that side effect over this. And then we put this back together. We use the rhombus array. You see these maybe delays and delays everywhere. That's because I didn't mention it, but we also do a lazy mode of the language too. So all the expansions potentially handle handle laziness. All right, and the type is an array of whatever that type variable is. Why is this so much code for indexing? What does it do? We've got the index and we've got the right-hand side. So we need to make sure that the index is a number, and the left-hand side here is an array of, and it's just a matter of looking up all those types and getting the new versions and putting them back together again. I guess because there's 3 pieces, that's why it looks like everything is done 3 times. The array, the index, and the right-hand side. So that's the update case and the lookup case where there's only 2 pieces. Data type. So the data type, this is where we say, this is implementing the type value and then these different cases. And so, well, what does it need to generate? It needs to bind value as a type. It needs to bind numv as a constructor, which is 2 things. It's a function to construct things, but also a pattern matching form. Okay? And we're building a simplified version of match for use in the class. So we do use match, but it's constrained to either list patterns or variant patterns like this, or syntax parsing patterns. So we have 3 variants of match that all look like rhombus match, but they're kind of distinct uses.
Can you also do dot within match?
Can we do dot within match? What do you, let's see. Generally, no. So we don't use dot in the rhombus-like way of if you have an X using X dot something to get a field out. Instead, right? So if somehow you know you've got a closure, you can't do that variable dot body. You can do close v dot body. There's just an accessor function. And we discourage students from using close v dot body because generally you should be using a match to get all the possible cases and handle them. And then you're doing a little pattern match to give a local name. Was that the question?
Right.
Yeah. So all I wanted to point out here is, well, you see lots of dot, dot, dots to map over all the variants with all the variance fields, and mostly that works out very nicely. There is a small catch in that here I'm making 1 names per each variant, and then I have the dot, dot, dot to go over all variants. And then I have every field within that variant. I'm mapping over it, but I want to refer back to, yeah, something goes wrong somewhere in one of these places where the dot, dot, dots turn out not to nest right. And so I have to make up an intermediate underscore X names to manually replicate things. So there's nothing rhombusy there. It's just the limits of the dot, dot, dot notation, which mostly works great, you can see, but every once in a while you hit that corner when you have nested things. But what this expands to is a namespace that holds the classes. And there's a namespace so that we can just rebind the names on the outside. So each variant name we bind as a macro that exposes the variance type. And we also bind it as a namespace so that you can have the accessors inside of there. And then it's also bound as something that communicates to match that says, I am a constructor, so I can be used in this restricted pattern format. Pattern, meanwhile, is implemented as a new space inside of Rhombus. So Shplait makes 3 or 4 of its own spaces for patterns to recognize things that are values for let-based polymorphism, to recognize types at the top level. And this making a new space and binding in that space solves a lot of things that would otherwise be mutual dependency problems. And just makes it sort of easier to extend all the different kinds of pattern forms that you have, and not have match be able to see all of those definitions directly.
Sorry, what's going on line 3?
On line 3, really, this one?
Like the coloring.
Oh, it's because I have spell check on, and stat info is apparently not an English word. So
Yep. Okay, makes sense.
yeah, if I turn off spell checking, then it'll go back to green. Okay. That's
Very cool.
the Shplait big picture.
5, so unfortunately I have to go. But
We are at the end of time, so
I'm very glad to be back in this meeting.
we're
I
glad you're
think
back.
we should say